Welcome to The Explainer. Today, we are diving into one of the biggest, most fundamental decisions you can make in system design, choosing the right database. It's really a choice between structure and speed. Let's break it down.
So, you're building something new, right? This is one of the first questions you got to answer. And trust me, your choice between a SQL or NoSQL database, it's going to shape everything that comes after. How your application works, how it grows, and how it performs when things get real.
All right, let's get into it. Here's our game plan. We'll start with the core blueprints, how they actually store data. Then we'll look at the growth plan. What happens when you need to scale? After that, we'll cover the rulebook they each play by. And finally, we'll wrap it all up to help you pick the perfect tool for the job. Okay, first up, let's get right to the heart of it. The biggest, most foundational difference between these two is their design philosophy, how they actually think about structuring information.
You can think of it like this. A SQL database is like a super detailed architectural blueprint. Everything, every table, every column, what kind of data goes where, it's all defined and locked in from the start. NoSQL, on the other hand, is kind of like playing with Legos. You got these versatile, flexible building blocks, and you can arrange and rearrange them however you need as your project evolves. So how does SQL keep everything so perfectly structured? Well, it uses these things called primary and foreign keys. Just think of them as unique ID tags that create these really strong concrete links between different tables. So a customer's unique ID in one table can link them to every single one of their orders in a completely separate table. That's SQL's superpower, making sure data is always consistent and related, which is perfect for running complex queries.
But NoSQL, that's a whole different story. It's not just one thing. It's more like a family of different approaches. There are 4 main types, and each one is built for a very specific kind of job.
First, you've got the key value model. It's the simplest of the bunch. It works just like a dictionary. You have a unique key, say a user ID, and that key points directly to its value, which could be a name or even a whole profile. This design is built for one thing: pure, blazing fast speed. If you know the key, you can grab the data almost instantly. Great for caching.
Next up is the document model, and this one is super popular. It stores data in these flexible documents, usually in a format called JSON. Imagine a single file for each user that has everything about them, their profile, their contact info, and a list of all their past orders, all nested right inside. This makes it so efficient to just grab all of a user's information in one single trip. Then there's the column family model, which totally flips the idea of a table on its head. The magic here is that every row can have its own unique set of columns. So one user's row might just track their last login time, but the next user's row could store a product they viewed, its price, and when they viewed it. This flexibility is perfect for big data, where you're just trying to capture massive amounts of different data points. And finally, the graph model. This one isn't about the data points themselves. It's all about the relationships between them. Data is stored as nodes, think people or products, and the connections between them are called edges. This is what powers social networks. It's built to instantly find complex connections, like show me all the friends of my friends who live in New York and also like hiking. All right, so that's how they're built. But what happens when your app totally takes off? When you're suddenly flooded with users and data, how do these different blueprints handle all that pressure? SQL databases traditionally scale vertically. We call that scaling up. It means when you need more power, you just buy a bigger, faster, and usually way more expensive single server. You're basically just building a taller and taller skyscraper on the same piece of land. NoSQL, well, it takes the complete opposite approach. It's designed to scale horizontally or scale out. So instead of building one giant skyscraper, you just buy more plots of land next door. You just add more and more standard, cheaper servers to a cluster, spreading the load across a whole fleet of machines. It's a much more modern, cost-effective way to handle massive growth. So we know how they're built and how they grow. But what about the rules they play by day to day? This gets into how they keep your data safe and how you actually, talk to them. SQL databases live by a super strict set of rules called ACID. It's basically an all-or-nothing promise. The classic example is a bank transfer. You take money out of one account and put it into another. ACID guarantees that either both of those things happen successfully or neither of them do. Your money never just vanishes. This makes SQL incredibly reliable, where data integrity is just non-negotiable. NoSQL databases often follow a different model called base. And this model puts availability first. even over immediate consistency. It basically accepts that for a split second, different parts of the system might be slightly out of sync. Think about the like count on a viral post. It might be off by a little bit for a moment, but it will catch up. It becomes eventually consistent. And that trade-off is what lets NoSQL achieve that massive scale and speed. This difference goes all the way down to how you talk to the database. SQL, the language, is universal. It's standardized. You learn it once, and you can pretty much talk to any relational database out there. But with NoSQL, there's no single standard. Each type, document, key value, graph, they all have their own unique ways you have to query them. So here we are at the most important question. With all these massive differences in design, in scaling, in the rules they follow, how do you actually choose the right one for your project? Well, you're going to want to lean towards SQL when your data is really structured, when the relationships between your data are clear, and when that absolute rock-solid data integrity, those AICID guarantees, are something you just can't compromise on. It's no surprise this is the standard in places like finance and healthcare.
But you should be looking seriously at NoSQL when your biggest worries are handling insane amounts of data, when that data doesn't fit neatly into tables, or when you need a schema that can just change and evolve on the fly. Here, speed and availability are king, which is why NoSQL powers so much of the modern web, from social media to big data.
And here it is, the whole story in one simple table. This is your ultimate cheat sheet. You've got SQL on one side, with its rigid schemas, vertical scaling, and ironclad consistency. And on the other, you've got NoSQL, with its flexible schemas, horizontal scaling, and eventual consistency. It really is the classic trade-off, structure versus scale. At the end of the day, the choice isn't about which database is better. That's the wrong question. It's about which one is the right tool for the job you're trying to do. So when you're thinking about your next big idea, just ask yourself this: does its success hinge on unbreakable rules and perfect integrity, or on endless flexibility and explosive speed? Your answer will tell you exactly where to go.